will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
Wait, was it?
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too late. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard before long, before it's too dark. Wake up, my love, please don't give up on me.
That is the mic. 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 Alright, can you guys hear me now? Alright, can you guys... Oh god, the audio is so bad. Alright, can you guys hear me now? Oh, why is that? The audio is so bad. Holy crap, what the heck is going on today? Oh man! All right. Oh, what was it? I'm gonna double check real quick. Let's just. Oh man! Oh, the audio is so bad. The audio is so bad. Right now I'm on my webcam mic. I'm not sure what's going on with my mic. Can I unplug and replug it in? Let's try that. And let's see. Testing. It says it's coming through on Streamlabs. Let's see if it actually... Oh, it's working now. Oh, okay. All right. I'm sorry, you guys. I don't know what the hell was going on there. That was really weird. My computer was actually giving me a bunch of issues earlier today. I had a couple beautiful blue screen crashes. Everyone's favorite stuff. But I think we're good now. You guys can all hear me, right? Yeah, let me send the donation link on that. The Twitch commands stuff is not set up. So if one of you guys want to set it up, one of you mods, whatever, you guys are free to set it up. Just waiting to see if you guys can hear me and someone responds in regards to being able to hear me, because I want to make sure, because the audio was coming through. So I want to make sure. Yeah, it's coming through when I do the things on the stream. You guys gonna help me out? Hello. Please tell me you guys can hear me. Oh no. Susana! Can you hear me on stream? Okay, there we go. I got 100%. Okay, sweet. Let's continue forward. All right, shall we? So, nonprofit. All right, this is the first time we have technical difficulties. So, today will not be rough, even though the rough starting is happening now. But donations, they're all 100% tax deductible. So, if you go on here, you can do a donation. You can claim some rewards. We have stuff all the way up to this beautiful, sexy sweater you see right here. And look at that. We got the Rootkill logo at the back. It is heavy duty, all right, but very soft on the inside, all right, I'll tell you. And it is awesome. Look how good it looks, all right. You want to get one, all right. So if you donate on here, you'll help us reach our goals, all right, like story time, 24 hours streaming straight, shaving my head, and then the one we will definitely, I encourage you guys not to get to, all right, is shaving my beard, because no one wants to see this shaved away. Also, we have an anonymous donor who is matching up to the first 10,000 donations on the stream. They will be matching them at the end of every month until we hit 10,000 donations, all right? So 10,000 from individuals, 10,000 plus from the anonymous donor equals $20,000. And me shaving my head, don't do it, all right? All right, get the merch, yeah, but just don't let it get too high, all right? I don't want to actually do that, all right? You don't have money? That's okay. Go over to our blog on our site. You'll see our week 3 giveaway. You can enter in the week 3 giveaway. It is free. Anyone can do it. And guess what? We're giving away one of these amazing sweaters, all right? So you can go get yourself, you can enter the giveaway. It's just subscribing to the YouTube channel, stuff like that. And you will be entered to win one of these amazing sweaters. All right, let's see here. So we're following our CompSci roadmap that we have on GitHub. Anyone can view and follow along. Everything that you need to know in order to get our cert is just posted for free. You'll have to, of course, do some Googling and teach yourself the items, but it is as free and cheap for anyone to get into and learn, all right? We're not trying to make too much money on the education part. We're trying to make money on not really the certifying part, but getting you a job, all right? That's what fulfills us, all right? So we talked about a lot of stuff already. Networking and protocols. We talked about wires and cables and too much about cabling, all right? But man, are you guys learning. We talked about internet speeds, how you measure things. We talked about how data is sent down these cables, the different methods that are used, the standards that are used about it. We talked a little bit about satellites and their footprint. We talked about the OSI model and the TCP model and their layers. OSI, remember, 7 layers. TCP/IP, 4 layers, and how they're kind of interconnected. How data is labeled at each one of these layers. We talked about APIs a little bit, and that will become more and more applicable as we get into the programming aspects. And then we talked a little bit about various pieces of hardware. All right. Lots and lots of stuff. Let's see. Will the matching go towards the total for the milestones? Like if you get 12,500 in donations, the other 12,500 is matched, and then you'll have to shave your head. Yes, all the matching is all going to be happening here live on this donation aspect. So it's not going to be like some weird backdoor deal that happens later on, or maybe it's just something we are saying. No, there's an actual donor, and they will be donating on this on this goal donation thing. So as you guys donate at the end of the month, wherever it's at, will be matched up to 10,000, not 12,500, up to 10,000 will be matched. All right, so let's talk about addressing. This is super important because you can lay a bunch of cable everywhere, connect a bunch of things, but how do you talk with each other at the end of the day? Super important. You can look at the real world, and that will give you a huge hint on how we go about this. We have addresses. We have houses. Think of houses as computers, and the world is the internet. And you have houses everywhere, and each house has an address. And if you plug in that address into your GPS, you can get exactly to the house you need to get to. AKA, if it was a computer, it will get you to the computer you need to get to. You're going to be going on roads, interstates, through cities. Think of those as various little servers and wires you have to get to your destination. But it is pretty much identical to how the internet works and how you go about doing addressing. All right. Also, you'll see a lot of similarities in addressing. For example, every city can potentially have the same road with the same like house addresses. All right. So if you live on 1234 Hacker Lane, there could be a 1234 Hacker Lane in DC, in New York, in Boston, in name insert city here. So you can reuse the same addresses over and over again. You can do the same thing in computer networking because of LANs and other fancy stuff like that, which we'll get into. Because, look, there's only so many characters you can put together to make something unique. So we reuse them with a little addition at the end, usually the city name, to make it wholly unique. All right? Let's see here. Any other questions? All right. We're probably going to be doing a little bit of drawing today because I know you guys love my drawings. All right. So it will help everything come together a little bit more. Let's see. Anyone here familiar with addressing, with things called unicast, multicast, broadcast, and anycast? Anyone here dived into this stuff before? And maybe can share with the group here what some of these items may or may not be. If not, don't worry. I have the answers. So all four of these, they have cast in the name because they're all related to each other. They're all part of the same happy group, the happy family, all right? They're just talking about various different like modes they are capable of. So forget about IPs, Macs. Let's think about it back at like houses and streets, or nodes and connections to those nodes, all right? Houses would be nodes, roads would be connections to those nodes, all right? Abstract. Abstracting is important. It's the best way to, or it's how most of these concepts are going to be illustrated, all right? So I got some lovely pictures here for addressing and talking about these guys. So just like getting post mail at home or email to an account, networking relies on addressing to get traffic to the proper destination. Addressing falls into four main transmission categories: unicast, multicast, broadcast, and anycast. All right, here's some lovely pictures to go with them, and these are exactly what it is. All right, and this is all you need to know for it. You know, unicast is addressing. The addressing is used to send traffic to a single host, a single node, a single place. All right, it's you sending data to one person. Multicast is you sending it to a group of people. Broadcast is like TV, you're just broadcasting over the waves. Everyone gets it. And anycast addressing maps traffic to the nearest host providing a specific service. Sorry. All right. That's it. Not too complex, right? So all of these graphics and stuff you can get when you go ahead and Google some of them, like Unicast. And let's go and look at our images, and bam, there's our lovely images right there. So I think did we get all of these from the Wikipedia? Yes, we did. So you can see right there, there's the Wikipedia. There's all the images. So you guys can utilize Wikipedia to help you out here. But that's it. That's the main concept. Nothing too fancy there. Any questions about that at all? Pretty graphics make everything easier, right? I think so. I like pretty graphics. So we talked about how you can basically send mail off to people. Various different ways you can send mail to an intended target, spamming everyone in a group. Just various different ways you can go about it. But in computer world, you have actual addresses that are going to be numbers. Now, we talked about one of them the other day, which was the MAC address, which is right here, Media Access Control Address. There's also another one called the Internet Protocol Address, your IP address, the thing that's in all the movies that everyone's scared of. Every 12-year-old on the internet's like, I'm going to get your IP and I'm going to hack you and blah, blah, blah. Just a bunch of nonsense. Yeah, that's the one we're talking about. So why are there two addresses? Because it's kind of confusing. Why would you want two addresses to potentially the same location? Don't worry, we're going to get into that. Specifically, we talked about it a little bit earlier. MAC addresses usually are only relevant when you're within a LAN, within somewhere close to you. And what makes this really unique until more recent times. It is actually soldered to the hardware device. It is implanted and completely unchangeable. It is physically made onto the device. It is an actual hardware address that is on the device, usually not actually programmed in. It is real. Because when you're dealing with items at this level, you're communicating with hardware to each other, and everything is processing the data as a hardware perspective. So you're basically not dealing with software here. It's actual hardware that's processing these messages. Something I don't know if we've mentioned before, but anything you can do with software, you can make it with hardware, because hardware is effectively software, in the sense of everything you make in software is built off of hardware concepts. So it's kind of a weird thing to think about and kind of trippy a little bit, but like everything, like an entire operating system, you can physically make that in hardware. You can make the entire Windows operating system with hardware pieces alone, no software included. It would probably be absolutely massive and complex, but it is possible. The great thing about doing things purely in hardware is it's super duper fast. And speed is an awesome thing that we love in the computing realm. So that's why in networking, which networking you always want really fast, these addresses are burned onto the boards, and that way they're capable of processing messages extremely fast and performing their logic extremely fast. The only downfall to that is it's immutable. It's soldered onto the hardware. It is there forever and it cannot be changed, which brings in the luxury of software. Software can always change. Software can be predefined, but you can always change it at a later date. And so IP addresses are going to live in the software realm. They can always change. Just because you have an IP address now doesn't mean it's going to be the same one later on. If you ever want to switch one, you can just switch one. It's software. It does not matter. It's completely changeable. And it's up to you on what it potentially could be. All right. And then we got this thing in the middle, which is our OUI, our Organizational Unique Identifier. You guys have actually seen this before. If you pull up Wireshark, which we talked about it, and hopefully I'm remembering this correctly. Let me Google this before I move forward. Oh no, not the 20 admin accept things again. Yeah, here we go. Come on. Okay, phew. Alright, sweet. So this is typically a part of your MAC address. This is what I talked about earlier with the switches and when we talked about Wireshark. So let me go ahead and load up Wireshark here. Not another one. So if you have Wireshark installed, you can go ahead and boot it up. If you haven't installed Wireshark yet, just go ahead and Google Wireshark. And this is the guy you need to download. And you can go ahead and download this bad boy. Let me go and paste it in here. And then you can follow along with this fun activity. Sweet. So this works not just for your device, but it works with potentially anyone you are communicating with. You can figure out what hardware they are on. So this is where you start doing snooping around, analyzing what you're communicating to, and the steps that a network analyst will take, or potentially a hacker. All right, because you need to know what you're trying to exploit or be on. So let me go ahead and press this red button here to stop intercepting traffic. So the OUI, what does it do? Well, when we click on traffic here, it doesn't matter where, and we look at the Ethernet layer, so we're going to see our source and destination here, which are both MAC addresses, and we'll get into the specifics of them here literally in like 2 seconds. But you would also see at the beginning, it's trying to say a brand name. One is ASUS and one is Arcanian. I don't know. Let's go Google it. All right, let's go Google and do some snooping around of what this hardware is. All right, Arcanian. Here we go. here's the company, 2003 Broadband Multimedia Company. So if we look, we get links to T-Mobile. And guess what? I don't have T-Mobile internet. I have Verizon internet. But regardless, they're pointing you to this device. This device is a router. All right? So now we have figured out that most likely this is the router that I'm talking to, and this is my computer. So now you know the ASUS. So if we look up ASUS, if you're not familiar with them, they're a hardware manufacturer. So they're the ones that manufactured my motherboard, and I guess they're the ones that made the Ethernet connector. So that's what my router is communicating with. So the OUI is the couple of bits, so the 24 bits of a MAC address at the very beginning that is a unique identifier for the manufacturer, vendor. It's a unique identifier for the individual that made that hardware device. So if we go to our next page here, it should be MAC addresses, right? Here we are. So MAC addresses are defined by IEEE's 802 standard, all right? MAC addresses are 48 bits in length, aka 6 bytes. So the first 24 of them, so the first half is going to go to the OUI, so the manufacturer. So if we look here, the first half of our MAC address, because we got the hex version right here, the 049226. That is the identifier for ASUS. All right. Every computer has this. So if you're on a Mac, a different type of manufacturer's laptop, maybe you got an Alienware computer or something, you'll see that they each have their own specific identifier. And then basically the last three are that unique ID they'll give you. Usually it's, they go with 1 and 2 and 3, and it keeps going up till it hits the max and it rolls over. This is kind of funny and something that you should know. You can run into issues if you get into the IT field and stuff. Again, remember, devices use MAC addresses to send traffic to each other within a LAN. So not in the internet, but below the internet, all right? Inside of a router. If you have a device with the same address, so let's say you are a fan of Cisco. Cisco makes a lot of switches, or Intel makes a lot of the Ethernet, the NICs on your board. If you buy a lot of their hardware all at once, there is the possibility that maybe more than one of them have the same MAC address. And if they do, you'll run into issues. So just be aware that is a thing that happens every once in a while. So just be aware of that, because this is a very small range of addresses you could potentially have, since there's only 24 bits usually. Let's see. They're burned into the NIC and used to deliver information on the Ethernet network. Often referred to as MAC address, they are typically in the format of 6 1 byte blocks. So if you see here, we have 1, 2, 3, 4, 5, 6 like blocks here with little colons between. So there are going to be 2 hex items, all right, hex digits with a colon to distinguish the next byte. That's the typical format for a MAC address. You can see right here, this is another example of one. All right. So it will be 1 byte, and 1 byte is equivalent to 2 digits in hex, and then colon is saying, all right, let's go to the next byte. This is the typical format, all right? Any questions so far? I see checking the playlist never came into my mind. I'm 17 days behind, but I will catch up. Thank you for your efforts, man. Thanks so much. Yeah, don't really worry too much if you're behind. You should be able to pick up on a lot of these concepts right now. Some things from before may build upon what we're talking today, but I think you'll be pretty good to start right here, right now. So let's continue on, shall we? So, pretty much just talking about the same thing. Let's move. We see the example. You can see Wireshark. You can see examples yourself. And we talked about this gives you your packets of data that's being sent across your computer. So you can see right here and analyze the actual raw data that's being sent from you to servers around the world, your router, and so forth. And you can see, those MAC addresses in here. And again, these are in hex also. So you'll see they're literally the same, B8. You can't really see my finger, but the B8 right here is the same B8 right here because they're both in hex. And we talked about the OUI is going to be the first half. All right. So this one is specifically for Apple. So FCFC48 is one of hundreds that Apple owns, that if you're using an Apple device right now, you may see something with FCFC at the beginning. There is a very special address that we're going to talk about next. Is there any downgrade to changing your MAC address with software? Yeah, not really. Not generally. Thank you so much for subscribing. Kilo Foxtrot. Awesome. That is super hype. Sorry, I'm trying to remember what I was talking about. Yes, changing your MAC address. So a lot of systems, even Windows natively now, allows you to do hot swapping of your MAC addresses or emulate it. Even my phone, I got a Google Pixel. I don't know about your guys' phones if you have Android. There's actually a setting in here when I connect to Wi-Fi that I can turn on to change my MAC address and constantly flip through it. It's a security precaution, especially if you're on public internet. It usually doesn't, it's not going to affect you negatively pretty much at all. The argument can be made that, yeah, it's potentially slowing down the traffic you're getting to your phone because typically things are hardware only, which hardware is very fast, all right? But now you're entering into more of the software realm, which is naturally going to be slower. So that's the only argument that can be made, but it's pretty much negligible. You're going to be A-okay. Answer that. Does that answer your question? So while you type, we're going to move on. So we're talking all here layer 2 of OSI model, because layer 1 again is just it's just electricity, right? It's just electricity, or if you're using fiber, light. Layer 2 is us interpreting that and using hardware now. So we're at layer 2. There's a special address that no one can use, well, no manufacturer can just use by default, but you can potentially use, and that is called the broadcast address, aka FFFFFF. They're pretty much just telling you just to forfeit, right? Or put some F's in the chat, all right? But it's just straight up FFs all the way across. And Fs, if you remember from hex is each digit is 16. So we're going 0 to 9 and then A to F. F being the highest value, which is going to be 15. So that means this is going to be, in the binary level, just a bunch of ones. All the way through, strike through everything, just ones. When this is present and hardware sees that, it will broadcast it and anyone is able to listen on that data. So if you have, where's my cool little switch over here? We talked about switches yesterday, and we talked about hubs and how switches will only deliver data where it needs to be delivered, and hubs will just broadcast. Everyone can listen to what I'm doing at all times. When you use FFFF, all that, all devices will broadcast it. So if you send it to a switch, it's going to send it to everyone else. It's going to start acting like a hub again. This is useful if you want other devices on your network to be aware of something. Let's see here. Yeah, I got it. Also, I have a Pixel 7 Pro, and that's where it came to mind. Yeah, I was surprised when I saw it on mine, I'm going to be honest. Let's see here. this can be very useful. We're going to get into some techniques here in a second on how it's useful and how it can be exploited, all right? We're going to talk about all of the exploits. Don't worry about that. An address of a value of 1 in the least significant bit of the first block signifies a layer 2 multicast address, right? So the least significant bit, which is a 1, all right? 1 makes things odd. So when you have your byte of information, 1 in the least significant bit, which least significant means it will have the lowest change on the value of that number, that will signify a multicast address. So let's get on to IP, the thing everyone wants to talk about. They think that they're going to be capable of hacking you or finding out something useful with it. Hence, not really. It can be if you know what you're doing, but most people don't know what they're doing, especially if they're saying stuff like that. They usually don't, they're just saying that just to say it because they saw it in a movie. IP addresses. So, we talked about MACs, which are hardware addresses. They're usually soldered on, but you can use software to emulate a different address if you want to. And we'll talk about that also. And when we get into the programming aspect of things, we'll even go over how you can go about programming that out. So you'll see in our next layer of our OSI model, NTCP, we hit IP, the IPv4, right? At least in this example, it's going to be our IP layer. There are 2 different types of IP versions, 4 and 6. We're going to talk about both of them. Why 4 and 6? What happened to 1, 2, 3, and 5? Great question. I don't really remember the answer to that. I think there was a reason, all right, but don't worry. There's no other versions between 4 and 6. I know it's a little weird. So that's going to be wrapped underneath your Ethernet layer. If I highlight over, so you can see in Wireshark, we got our whole packet of data. The first part of it is going to be those 2 different addresses. The next is going to be our IPv4 addressing. There's more than just our IP address in there. There's also some extra information in there. And we'll be getting into that here. Don't worry about that. Here we go. IP address. So source and destination address. So this source address is my computer, and it's going to this destination address. So this address, go ahead, try to use it to get to me. It won't work. Don't worry. I'll explain later why this one won't. But this one, we can see actively what I was trying to access. So if we go into our browser here, and we type in 74.125.155.102, hopefully it's nothing embarrassing, bam, it looks like it is a Google server that I was talking to. Most likely this is the stream. So yeah, it looks like it was stream traffic. So this is the server that when you stream on Google, you could be potentially sending your data to. This is the internet address for one of Google's servers. So this is useful information because, again, when we're in IP address realm, we're talking about the internet. And so that means it's usually associated with servers. All right? Any questions in regards to that? And the same thing applies when you talk about IP addresses. You can totally make up new ones. You can mask yours. You can do a lot of weird and fun stuff. All right. So let's go through the book part here a little bit and talk more specifics. While physical addressing handles the delivery of data over the same local network, so your LAN, logical addressing is what makes internet work communication possible. Although multiple logical addressing standards such as IPX and AppleTalk do exist, the most prevalent logical address is the Internet Protocol address, your IP address. Again, this is software, and it is standardized and you can follow the standards and be able to easily communicate with everyone else following the standard. But guess what? You don't have to. You can be a rebel and make your own protocol. All right. These are some that exist. Apple Talk. So Apple makes their own. I don't think they even support Apple Talk anymore. But you can make your own. You could totally do that and then publish it on GitHub and see if people want to adopt your standard. Most likely not, because IPv6 just rolled out. A lot of money went into that and people are utilizing it everywhere right now. So it would be a hard sell. I see. I always wondered why local IP addresses usually started with 192. Is there a reason for that? Great question. There is a reason, and we're going to get into that. Don't worry. Don't worry about that. You're going to learn more than you ever thought was even possible, or literally you're going to be sitting here after we're done with the day and be like, how is this so deep? Why is there so much information of this? Like, a lot of things here are taken for granted. So again, these are like the housing addresses, but at the internet level. So if we move on, a IP address identifies each computer using this protocol to communicate. Although the term IP address would correctly cover both IPv4 and IPv6, it is specifically referred for IPv4. All right. Now, each one of your let me just read this. IP address consists of a set of 4 numbers, each which can range from 0 to 255. Now, if we take, I pressed the button on my mouse. If we take a second there, for those of you that went through basic math with us, and we talked about binary data, this should seem very, very familiar. Because when you have 1 byte of data, which is 8 bits, the max number you can have for an unsigned integer is 255, which if we count 0 as a valid number, that means you can have up to 256 different numbers. All right. These are referred to as octets in an IP address. Why? Because why not? They wanted their own special name. All right. Why can't they have their own special name? Byte was too much for them. They wanted to call an octet. Just like RGB color codes. Correct. Just like RGB color codes, right? It comes into the same reason. That's going to be a byte of it will be the 3 bytes of information for most RGB codes. All right? And this is exactly why. So, an octet, 8 binary digits, aka bits, or 1 byte. So usually there are decimal places. So again, these people, look, these were a bunch of nerds that were doing their own thing. It's no different than right now. All right. They think they're super cool and special and better than everyone else. So that's why you get MAC addresses and they're like, we want to use colons because we think colons are cool. All right. And then you get over into IP realm and they're like, you guys is colons? That's friggin' stupid. Like, we're going to just use periods, all right? So they use periods. That's just what they chose, and now it's stuck like that. There is no logic behind it. Don't try to read into it or figure out why. It's just what someone decided a long time ago, because in the early days of the internet, it was the wild, wild west. So whatever was made is gone and is taught that way. So we can see there's an address here, 192, 168, 10, and 150. In binary, it would look like this. We can also translate it to hex if we want, because again, 1 byte of data turns into 2 hex values, all right? But this binary, too much to read there, all right? I'm lazy, I'm a programmer, I don't want to read all that. Hex, I could get behind hex. There's less digits potentially than decimal, but I guess I'll settle on decimal. So we're settling on that. So IP addresses consist of 2 distinct portions, and this will get into answering your question here that you had in regards to 192. The 2 distinct portions, one is the network portion and one is the host portion. Because think of it like this. You're in a neighborhood, right? You live in a neighborhood, or maybe you live in an apartment building. It will work for both of them. I'm going to go with the neighborhood example, but you can apply the apartment number to the same example. Your neighborhood will have a street. That street is your network. All right. There is a certain amount of houses that were first allocated by the state that could be made, or the city, or whoever manages land for your area. They dictated how many houses are allowed to be along that street. All right, that's the network. The total amount of houses that are available is the network. Your host is going to be the specific houses. So you may live on Hacker Lane, that's the network, but your house, your host portion, your house number is going to be 1111, right? Together, they make your full address. In here, together, they're going to make your full IP address. So the network ID is a portion of the IP address starting from the left, so this side, that identifies the network segment on which a host is located. The host ID is the portion of the IP address that identifies a particular host on a network segment, aka whatever's potentially left over. The host ID for each host must be unique within the network ID. So within a network, your host ID must be the same. Think about with like the house example. Your house number needs to be different from everyone else's on that street. Or if you're in an apartment, your apartment number needs to be different from everyone else, or else you're going to be getting mixed mail. Maybe the same person with the same apartment number as you walks into your place sometimes on accident because they get confused. A whole mess of things can happen, all right? So remember, you got to have unique IDs. Any questions so far? Let me get a drink here. So, to distinguish these networks, all right, this is going to be a lot of numbers here and a little bit of weird math. Just stick with me, all right? We're gonna get through it. There's this thing called a subnet mask, and it's a number similar to an IP address that defines where the network ID stops and the host begins. Because if you look at this, to the untrained eye, you wouldn't be able to, if I tell you there's a network and a host and I tell you where, that you need to figure out where the network starts and the host stops, it's going to be very hard for you to figure out. And for some addresses, it may be very ambiguous. So you need a second piece of information that will tell you where the start-stop point is. So we have these things called subnet masks, which will basically tell you how big your network is. So let's see here. In a subnet mask, a binary 1 signifies that the corresponding bit in the IP address belongs to the network portion. A binary 0 signifies that the corresponding bit in the IP address belongs to the host portion. So in here, so we got an IP address right here, slightly different than this one, all right? So let's just focus on this one. Let me zoom in a little bit just to really emphasize this. I give you this IP address, and I ask you what street they are on and what house is theirs. You can't really figure it out by just looking at it. You need to have the subnet mask. So it's best and easiest if we split it up to its binary values. So this is what your guy is in binary, the number up above. This is your subnet mask in binary, which translates to this number. So according to that rule, anything with ones means that those digits up above belong to the network. So you live on this street, aka 198, 168, 1 is the street that you live on. And this is your actual house number. So if I ask you this question, even though we haven't even talked about this portion yet, if I ask you, on this street, how many houses could potentially be built on this street? Or how many computers, in this case, could be connected to this network? And your answer would be, can anyone guess? I know you guys can get this one, all right? it would be 256 because we have 1 byte of information here left over for the host section, aka the house addresses. This is for the network section, aka the street that you live on. The street that you live on takes up all this information, all right, to write it down. So you're only left with the unhighlighted part, which is 1 byte, and 1 byte can be up to 0 to 256, but we count 0 as a legit number, so the total potential values you could have is 256. All right? So that's how the submasks work. Any questions in here on submasks? Do we need any more clarification before moving forward? Because we're going to be talking about subnets and subnet masks more here in a second, because they are a very important thing that are used all the time. And this is actually really important when we get to the programming section, and if we start touching on how you can program with other computers and connect those computers and send data between them, you're going to need to know this information, because you won't be able to send things correctly in between each other if you don't understand it completely. So if I ask you guys, if this is my IP address, if we look at this example right here, 198.168.1, and we look at my IP address right here, which is 192.168.1, they should look kind of familiar. Now, we can't guarantee what the subnet mask is or the network is for this address, but we can probably guess and assume what it is based off of what we just learned here. And you probably will be correct. All right? There is a possibility that you are wrong, but most likely you are correct. And we'll get into that reason here in a second. All right, let's chug along to the next section. So first, let's show off this. We're chugging along these guys, and we're going through all of them. And again, this is set up for you guys to easily Google them. So if we take subnet mask and we Google subnet mask, you will see YouTube videos that pop up and a bunch of definitions that pop up. So don't worry. If you don't quite understand something, there's plenty of other resources that you can utilize in order to learn this stuff. So let us continue forward. Next page. Let's talk about IP address classes, shall we? This should make a lot of things. Is it going to be this one? I think it will be the next one. Basically, people like categorizing things, so we categorized IP addresses in their ranges. So anything with these specific items are going to be defined as class A, B, C, and D. Let us go ahead and Google this. IP classes. Exactly. It's a C category, but there's more information on that here in a second. All right, that's why we have the graphic we do, because this is no bueno also. So what this is basically saying, if I can, did I pass it? All right, so A is basically saying that you have an address that is class A if the first, this mask is your subnet mask, if the first octet is purely defining the network you are on. You're on a class A network. If the first two octets are defining what network you are on, you have a class B network. If the first three are defining what network you on, you have a class C. And the D and E are going to be for multicasting addresses and finally some experimental stuff. And you'll see this thing called CIDRs, which we're about to get into next. So there's just ways for you to categorize the data. Let's see if there's any good resources on this also. Not really, but that's pretty much the chart I would recommend. Yeah, I think these are charts that we were copying. Let's go to the next one. Subnetting. All right. Subnetting is another term for your masks, and they just needed to make it more complicated. All right. It's called CIDRs. All right, is what we're introducing here, and you're going to see this. We're going to go through an example of some CIDRs here on your computer. All right. So on your computer, if you're on a Windows computer, you can go ahead and click the Windows key on your keyboard and type in PowerShell, or you can click on the Windows key and then type in PowerShell. And this is the only setup you guys have because you're devs now. So you're definitely going to make sure, and you're definitely not going to have this search box here because that's what plebs have, all right? You definitely, right, went in here and you clicked on hidden to hide it, right? Good. I'm proud of you guys. I know you guys did that, all right? So, I'm a pleb. Oh no, don't admit that. Don't admit that in the chat. That's not a good thing. So if you guys haven't already, for the love of God, go to search, hide it. Go to news, turn it off. Turn off the Cortana button and turn off the task view button. You don't need them, right? You don't need them. They take up too much space. Just get rid of them. Looks so much nicer, so much cleaner. So let me go ahead and make this bad boy a little bit bigger. And size of the font, let's go 36. That big enough? You guys can see that? So if you're not familiar with PowerShell, don't worry. Command prompt will be the same if you're familiar with command prompt. If you're on a Mac computer, right, you're going to search for terminal. So if you do 5 fingers together, you'll bring up your app screen, type in terminal, and then you can click on what shows up, right? And then you can follow along with us. Any questions so far? Is anyone confused on how to do this? If you are, go and put in the chat, and we're going to move forward. So in here, if you guys aren't familiar, we're going to get into this more specifically when we get into operating systems next. We're going to talk too much about the terminal. This is how you interact with your computer. This is how you interact with your computer before we had pretty graphics. This is still the standard, the gold standard for how you communicate with your computer. Why? Because there's no pictures. So me as a dev, I don't need to waste my time making pretty pictures. I can just deal in the realm of text and tell you, hey, if you want to click on a button, you can just say like tack button 1, right? That's way easier for me to program out than me making a button and then figuring out where to place it. And God, don't even get me onto, oh, you need to support tablets and mobile, and ugh, no one wants to do that. It's too much wasted time. So Terminal LAN is simple LAN. In here on Windows, specifically if you're using PowerShell, PowerShell lets you use Linux and, well, they alias some commands with their Linux counterparts. If you have a Mac computer, all Linux commands * work on your computer because guess what? Mac OS is Unix based, which Linux is also. You guys are the same. Hashtag Linux Army. Hashtag please don't run Linux as your main OS. Just don't, all right? So if you go and type in ifconfig or ipconfig, my bad. If you type in ifconfig on your Mac, and if it's ipconfig on here, I thought they were aliased, but maybe I am wrong. You're going to get a lot of information here. So ignore a lot of it and find exactly how you're connected to the internet. I'm connected to the internet specifically through an Ethernet cord. So this is the information I want to look for. Yours may be an Ethernet cord also, or it might be the Wi-Fi card. So you'll see something here for Wi-Fi. You're going to want to look for that. Here you can get some useful information for what we've talked about. See, there's a question, why Windows has both CMD, terminal, and PowerShell? Great question. CMD is legacy, so command prompt is legacy, and it's goes back to the original days of Windows. PowerShell was their new take and their new version on it. They made a whole language, a scripting language for it called PowerShell that you can utilize to automate a lot of stuff. There's a huge cult following around PowerShell. Windows Terminal, which I don't have installed right now, it's not anything new. It's just a browser per se, and all it does is will load up CMD or PowerShell if you tell it to load up one or the other, or if you're using the Windows or the Linux Windows Linux subsystem, you can also open up your Linux terminal on there. I just am able to open up directly if I type in Ubuntu. So I'm not quite sure. I thought I installed Windows Terminal on mine, but I guess not. Back to this, you can see your information, including your IP address for your computer. All right, that's a very specific thing to distinguish here. It's for your computer, and I'll show you here as we move forward why that is important. Below is your subnet mask. So I talked about earlier when we were looking at Wireshark, we could probably assume, based off my IP address, that my subnet mask was going to be the same as it was in the book. And if we look here, this will confirm our subnet mask is exactly the same as the one from the book. All right, and this would be what type of class of internet? Give you guys a little hint here. Look right here, the default mask. That's right. It would be class C. So the first octet, so these are your first numbers in the IP address. They need to be matching this, all right, first and foremost. And if they match this first and foremost, and then match the rest of this stuff, then you know you have that class of internet or IP address. And then you'll usually see this thing at the bottom called your default gateway. That is your router. That is your guardian, your gatekeeper, your gateway. That keyword gateway we gave earlier. It's the gateway to the internet. It is sitting there protecting you and stopping everything coming your way. Routers will have 2 IP addresses, at least. They could have more than that. They'll have one for your LAN. So let's bring up good old Paint here. And then once I talk about this, we're going to go ahead and take our 5-minute break. But this time, let me use some shapes because, oh, that was not a shape. Because we haven't used shapes here. So we got our LAN here. And, ooh, I think they have the cloud. They have a thought bubble. So we're going to use a thought bubble here for the internet. And I'm just going to draw because it's taking a little too long. And we got our router. R is for router. Now our router is our gatekeeper, which means it's what makes our LAN and is touching inside of our LAN, but it's also touching outside to the actual internet. And again, it dictates what can come in to our special protected LAN and what is allowed to leave our special protected LAN. It will have 2 IP addresses. One is going to be for within the LAN, and it's usually almost for pretty much everyone at your house, it will usually always be 192.168.1.1. Sometimes it could be 0.1, but it's usually 1.1. That is the most common one you'll see. If you go around anywhere you connect your laptop moving forward, you can always see what the router's IP address is if you run that command, ipconfig. If you're on a Mac or Linux computer, it's going to be ifconfig. Why they didn't get with the same program, I don't know. So ipconfig, you can guess, stands for IP, Internet Protocol configuration. Linux, they have it as ifconfig. If is your interface config, right? Your interface configuration. So you'll also have an external IP address. So if we go onto Google and we say, what's my IP? This IP is also your router's IP address. Can I move it right here? There we go. It is also your router's IP address. So mine, in this instance, would be 68.134.168.25. All right. So my router has two IP addresses. When people on the public internet want to communicate with me and my router, they will be going to this internet. Your router is also like a mini server. So when I talk to a server like google.com or something and they send data back to me, you don't actually use this IP address of your computer because this is in a special protected area in your LAN. They actually send it to this address, to your router, and your router will then receive it and then route that traffic to you within your LAN. And we'll talk about how it does that specifically here after the break. All right. If you have any questions while we're on break, go ahead and drop them into the chat. If not, we'll get back to it and move forward. So I'll see you guys. Oh, I don't even have my lo-fi music playing. We are all messed up today. There we go. Things are right now. Things are just. So we got our music playing. We're happy now. We're going on break. Be back in like 3-5 minutes. Alrighty, alrighty. We are back. Let me turn down the music just a little bit. Where is the music? Let's see here, just a tad. Perfect. Alright, let's check the chat here. When I go to the public internet places, sometimes they leave their router username and pass on the default, and I change their Wi-Fi name to Smith Silly just for fun. That's actually a great thing to point out. So, looking at this command, we got some great useful information. We got some information about our computer, but we got some also about our router, which is our gatekeeper. So anytime you connect to the internet, anytime you connect to a router via Ethernet cord or Wi-Fi, if you're at the airport, if you're at work, if you're at wherever, Starbucks, wherever you're connecting to, if you go to this address, you will get to your router. Typically, asterisk, it will usually lead you to your router. So if you have recently set up, or if you can remember back to when you first set up your router, typically it will tell you to go to that address. So if we type in 192.168.1.1, this will take us to our router's portal. Usually they are not encrypted with HTTPS. This one is, but it can't verify the certificate. Don't worry, we'll get into that stuff. But if we continue, you can see here is my router's login portal. And this is a web server hosted by your router that's only accessible inside of your LAN. Anyone in your LAN can access this unless you go in and you change the passwords on it. And this is how you set up things like your internet name, your internet password, and so on and so forth. So if you are on the default stuff, you should definitely change that, because the default username and passwords for these devices are usually posted publicly. So anyone can log in and mess with your stuff in potentially really, really bad, malicious way. So let's move on here with our book. So subnetting. Me telling you my subnet mask is 255.255.255.0 or 111.111 blah 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 is a lot. All right, we're programmers, for God's sake. We're people, or IT people, whatever you. This is also a lot of stuff that IT people will be dealing with. We're lazy, man. We don't want to do this. We don't want to say things, extra words, if we don't want to say them. We want to say them the minimal amount, have the most minimal communication with other human beings as possible, so we can go back to our cave and dwell in our darkness, all right? Saying it is too much. So what do? Someone said, all right, let's use CIDRs, all right? CIDRs are basically a short-term way of saying what your subnet mask is, but in one single number. So you'll usually see IP addresses like this. Also, it condenses all the information. This is an IP address, and then it has a slash at the end of it and a number. That is your CIDR, that is your subnet mask. All right, that tells you where your network is and where your hosts are. What is this number? Good question. The number is the amount of ones. So if you count up all these ones, well, we know each byte is 8. So we have 8 times 3. So 8 plus 8 is going to be 16. And then 16 plus 8 is going to be 24. So that's why it's going to be a CIDR of 24. So that's how we can figure out also what type of class it is. Because if we go over to our classes, you can see they also talked about the CIDRs here. The CIDRs are how many ones you'll have in your mask. All right. Now, you can have your mask be anything. It could be a mask of 23 or 22 or 21, whatever you want it to be. You can set that as your mask. These are just the typical ones that you'll see out in the wild. but your mask can be however small or large you want it to be. Any questions on that? Oh no, your computer crashed. Welcome to my life, all right? I know the feeling. I know the feeling too well. All right. So when you do this, when you take a network and you put a CIDR mask on it, it's called subnetting. You'll also hear this buzzword thrown around a lot in the movies, and it's it's very, very cringeworthy. Super cringe, and now I'm going to ruin a lot of movies for you guys, alright? Now when you watch a lot of movies and you hear them saying they're hacking the subnet, alright? It's very cringe because it doesn't make sense half the time, alright? Subnet is basically you taking something that's big and making it smaller. So this right here is going to be a great example of a subnet. So you have a connection of, here, let me pull up good old Paint. So you have 192.168.10.0/24. So if we look at this, we can tell from what we've been using before, which have all been CIDR of 24, aka networks where this right here is our network, and this is what's left over for hosts. So what we're saying here is our network, our road that we live on is this address. All right, and we can have up to 255 computers on this road. But see, we aren't governed by the government here. We are in the free realm of computer and computer science, which means we make up the rules. We tell people where they can live and how they live, and we are God, all right? So try to understand that moving forward. You are basically living in God mode, and you can dictate things however you want them to be. So you can utilize something called subnetting. Let me write it over here on the side. Subnetting. Subnetting basically says, hey, I see that you just gave me this road. Let me draw a better picture of a road here. You gave me this big road, all right? And it's capable of having, it's just one network, and it's capable of having 255 houses. Sorry, 256 houses. But I want there to be more than one road. I want to take this road and I want to say I'm making my own neighborhood, and instead I want 2 roads. Cool. You can do that if you would like. As long as you're working in the constraints of your of the road that you were granted and given, you can turn that one road into 2 roads. I'm trying to think of a good way to. Yeah, I'm just going to draw a line here. There we go. I just split the road in half, and now I have 2 roads. So you can utilize subnetting for that. So again, you can use whatever number you want at the end of your CIDR here. So if we say we want there to be 192 networks, so 192.168.10.0 with a CIDR of 25. And that's our one network we're making out of, so we have our big master network here, and we're going to make a smaller network here with 25, and we can make now a second network with 192.168.10.127, right? 128/25. So I said I'm the government. I can dictate what I do with my road, and I say I want to make my road into 2 roads. You can do that. So now we've made 2 different networks from the same parent network. We're not going over the amount of hosts that are available. There's still only 256 hosts available in total. But now with these new networks, since we're using a CIDR of 25, we have a total of 128 and 128 networks that we can now, or hosts we can now have on these 2 smaller networks. So basically we're just taking it and cutting it in half. All right, the CIDR is important because again, the CIDR tells you what is the housing or the road that they live on. All right, and you gotta always remember we're dealing with data, aka binary data. So when we say 25, if we look at our ones right here, this is at 24, and to make 25, we need this as a 1 here. All right, which means this value, when this value is a 1, it will distinguish us being on a new network, effectively splitting in half. And that's why if we look at the rest of the data here, that will give us 127 max, which 0 to 127 is, you guessed it, 128. So one network, where did I put my paint? There it is. This first network starts at 0 because it says 0 right here. And so it can have house addresses from 0 to 128. And this one starts at 128. So it will have house addresses or computer addresses to 128 to 255. We're separating our networks, our communities. Why is this important? Well, if you have one LAN, one network where everyone is on, cool, that might be fun, but maybe you value your privacy, all right? Let's say you and your neighbor can only get, for some reason, I don't know why, but you guys can only get one internet, one internet cable running to, like, in between both of your houses, all right? And now you guys need to share it. You could just openly share it and be on the same network as your neighbor. But if your neighbor is a little crazy, you know, he may want to snoop on your connections. And if you're in the same network, they can do that. They can openly look and snoop on you if they wish to do so. So you can basically separate your networks so they are on their own little LANs, and now they're isolated from each other. So now they can't snoop on you. All right? That's why you do this. You do it to break things up and compartmentize each one of them. When will you see this used? Well, you'll see this used a lot in businesses because you might want your HR department to be isolated on their own network so they're not doing anything weird, or if one of them get hacked, they can't the hacker can't easily jump to, let's say, the engineering department because they're on their own isolated network, all right? So you'll see engineering will be in one area. HR will be in a different, maybe the C-suite or S-suite or whatever they're called will be in a different place, and your photo people and so on and so forth, all right? Think of it as subnetting as, I guess a great example would be a business building, a business place, and you cutting up each department. You still have the whole space of the building, but you're cutting everything up so people are isolated and in their own little areas. Does that make sense? Are there any questions there? Is this something a lot of people do in their own home? No, this is not something people do in their own home. Typically, there are some weirdos that do that. I mean, if Taylor, are you here? That is one of the weirdos. It's not typical for people to do it. It does not mean you can't do it, because you can, but it's not typical for people to do it. You said do. Oh, you got me. All right. Calling out Taylor like that. Taylor does some extra stuff, right? He has a big server rack at his house. He is on a little bit of a different level. Sounds like the logic of Qubes OS. Not familiar with that operating system, but maybe it is. it's something that you will use in the business place. So for example, Rootkit, we have software projects we're working on, specifically Project 26, and a security measure that you'll commonly take as a developer when you're developing stuff in a microservice architecture. So we'll get into that when we get into the programming section, is that you want each microservice compartmentalized. So think of microservices as separate parts of the same application that are distinct. So maybe one's for like users that are on the application, and one are for the admin portal, and another service is for a ticketing system. Those are distinct systems, and to keep each one secure, in case one ever did get hacked or breached, you would subnet each one, because there's no reason ever why the ticketing system should ever be interacting with the HR system or the finance system, all right? So you compartmentalize them and you keep them in their own little sphere, and they can only see and talk to people that are in the same network, all right? They can leave the network if they want to talk to the internet, but they can't interact with anyone else's personal networks. LANs, again, are small areas for small niche like communities, quote unquote. That's just an illustration point for it. All right, so big takeaway there. Subnetting allows you to take something bigger and break it up into smaller pieces and segment them off. Think business building and then departments in a business building. Now we're going to talk about supernetting. It is the exact opposite of subnetting. It is taking multiple networks and making a bigger one, right? When subnetting, the number of available hosts are sacrificed to make more available subnets, all right? Because we're cutting it up, so there's going to be less hosts. We saw that we were taking it from 255 to 128, 256 to 128 for each subnet. Supernetting is essentially the opposite of subnetting, in that network bits are taken back to utilize as host bits. This act decreases the number of networks that you can potentially make, but increases the number of assignable IPs in each network. All right. To supernet IPs, an organization must own the network from which the bits are borrowed. So if my internet provider, I want Paint. If my internet provider, let's say, this isn't the case for this address, I'm using it as an example only, but if they said, this is all the IP space I'm giving you is 255 IP addresses, this is all you're gonna get, then I can't super net anything larger than that. But if I have broken this up into multiple subnets, I can potentially do super netting in order to make a larger network. And to roll back for subnetting to a second, I gave an example of us splitting up into two, but you can split it up into as small of segments as possible, as you want. Like you can go literally as small as you want. I just went the most simplest route with just showing two. All right. So big thing, supernetting, exact opposite. So is it like Docker containers? Yes. So Docker containers, that's a kind of a more advanced concept. That's what we require for our advanced computer science certificate, which we highly recommend because it makes you even more valuable if you know things like Docker for employees. Employers. It makes you way more valuable. All right. So Docker containers especially if you use Docker Compose, they'll create their own network. So mine's closed right now. We'll have it open up and I'll show it here in a second. So this took us a while, but going back to your question, Luch, let's say that's your name. I pronounced it correctly. All right. Now we're going to get into answering your original question. All right, we were building up to it, and now we're going to answer it by going to Docker for a second. When you have clusters like this, Docker will also make networks for them with different that are subnetted and will have their own IP ranges. I don't know if there's an easy way off the bat here to show that, but there are command lines, things you can do to see the networks that exist. All right, let me see. All right, good, we're good. So there are these things called private IP ranges, okay? So pretty much the IP addresses that are typically available are pretty much all free game. There is anyone at any time, you're including yourself, can technically assign any IP address you want to your computers. There is no laws. Look, we are in software land. There is no regulations. There are no laws. You can do anything you want. This is just data. There are regulations like IEEE and OSI that will try to tell you how you should go about your business, but no government agency in the world enforces them. You can do whatever you want. This is not like building houses where houses have codes you have to adhere to. The internet is completely wild. You can do anything. No one is telling you you have to conform to this standard. All right? That is also a separate issue, which I wish there were government codes to help standardize and enforce standardization, but there are none. So everything we talk about when it comes to computer, data, when we talked about the basic math section, hardware, and getting into the IP stuff, it's an honor system. That's all it comes to at the end of the day. It is an honor system that could potentially be broken at any minute if anyone wants to break it. And there are lots of historical news pieces you can read about where people weren't trying to break things intentionally. It was done on accident, and then it ruined things. And I'll talk about those here in a second. So on this honor system, we can have IP addresses from 000, 0000 to 256, 256, 256, 256. Those are all IP addresses you could potentially have. Except not really, because people have, in general, come to an agreement that, hey, at the A class of IP addresses, we all agree that no one will ever use any of these IP addresses except when they're using it in a LAN. All right? In the B class, no one's allowed to use these IP addresses except if you're in a LAN. And for the C class, no one is allowed to use these IP addresses unless they are in a LAN. These are known as your private IP ranges. You will never ever see a public IP address within this range ever, because it's just not, people don't allow it, right? Even though you could do it, they don't allow it, and you won't be allowed to route traffic to it because they're going to block it for the most part. So this is what you'll see most commonly on your computer when you look at your IP address, or when you're on any type of route like internet, when you connect to the Wi-Fi and stuff, because this is your private IP address. So 192.168 is one of the most common ones, which means that you can have up to, so this is a CIDR of 16, which means both of these are hard set. This is your network, which means both of these are free for all on how much space you have. So that's 2 bytes of information, which is going to be, what? 2 bytes are, I'm blanking right now, 1024 different devices you can connect to the network, right? I think that's too low. I think it's 65,500 and whatever that number is. But that's how many devices you can connect to this network. That is usually, asterisk, good enough for most people. Now, just because by default your router uses this IP range doesn't mean you have to keep it that way. You can change it. You can change it to any 3 of these that you wish, all right? Because these are private IP ranges, which means they're free for all. You can use any ones that you want. So if you have more devices than this, which if you're working in a business setting, you may want to use the B class. Typically, now that you bring it up for Docker, everyone else who doesn't know what Docker is, don't worry about it. All right, we'll talk maybe about this later on. This is more advanced stuff. Docker by default will use IP addresses within the 172.16 range because you can potentially have lots of containers running at once. So you need more network bandwidth. And if you're at a business, most big businesses will be using the A class of IP addresses because they'll have lots and lots and lots and lots of devices. All right. Any questions on this? There are 2 additional ranges that you should be aware of, which is going to be 169.254 of a CIDR of 16, which is utilized by Windows machines specifically for your DHCP. And then there is 127.0.0.0.8. You will never see these in the wild, all right? This is your loopback address, aka this is a very special address that your computer uses to basically talk to itself. Whenever you send network traffic on this, it will send it right back to yourself, all right? Yeah, 65,535. That sounds correct that's how many devices you can have on this network if you don't subnet it up. So in total, that's what you can have. Because remember, this tells you, these numbers, these CIDRs, are telling you how much is going to be static, aka your network, and then how much you can dynamically change and fill up as your hosts. Let's go. Machine has been configured with DHCP for whatever reason. It is unable to contact the DHCP server. The host will assign it the address here. Process is called, okay. So what's the purpose of routing back to, great question. What is the purpose of routing back to yourself? We'll get into that here in a second. I'll go into a code example for that. Let's see here. So this IP range, by default, if you're running a Windows machine and you're having issues connecting to your router, on your router, it runs this very special server called a DHCP server, which its job is to allocate IP addresses. And we should be going over that up next. Basically, if you're having issues connecting to this, you will see that your Windows machine will go to this address by default. So when you do IP config, you'll see this address, all right? So it's called an AppIPA, which is an automatic private IP address, specifically for Windows. So 127 is going to be your loopback range. Loopback is a virtual interface configured for maintenance and management functions. Also, it should say in there development functions, all right? But typically maintenance and management. Although 127.0.0.1 is commonly used as your loopback address, the entire 127 range or subnet is completely available for your loopbacks, all right? And it's used to test your NIC's ability to send or receive network traffic at times. So if you have Wireshark installed, I just updated you. How do you have another update? You'll actually see sometimes in here, let me see if I can find some loopback address traffic. Actually, I think that was a different device. So if oh no, what am I doing? Let me go to, not open. You'll see this whenever you open Wireshark. Is it here in settings? Here we go. So in the different options that you have, you will see that there's something called adapter for loopback traffic capture. This is for capturing all traffic that's being sent across your loopback range, aka 127.0.0.1. All right? That is a thing that exists, and that is why that is there. It's for you talking yourself. Look. Shouldn't be that big of a surprise. Come on, we're programmers. We're alone. It's dark. We have no one else to talk to except for ourselves. So we had to program it so the computers kind of emulate that. You know, we don't want to be the only ones talking to ourselves, or else we look a little crazy. You know what I mean? So we have our computers talk to themselves too, so we're not alone. All right, so they made them in your image. Yep. So loopback address. Let's talk about that for a second. What's a quick example I can do? I'm blanking right now. Basically, you can type in 127. Do I even have anything running right now? 127.0.0.1. If you run that, it will usually just hang and then go to a refused. If you're running your own little server or something on your own computer, you'll see that it pops up. Do I have XAMPP installed? I do. So if this will load up, and if it will work, fingers crossed. I don't know if it will work. Oh, is it working? Hey, look at that. So what this is doing, all right, is it's a server application. So it's allowing me to host websites, make my computer into a web server. So to do testing on whether this is working or not, I can type in 127.0.0.1. It's basically saying, hey, I want to look at the web server on my computer. So that is a useful use case of you talking to yourself, because you want to talk to yourself to see what you're hosting on a server. Usually you'll see this aliased with a specific key name. You might have seen this before. It's going to be localhost. Localhost, all right? When you type in localhost, you'll see it went straight to this. This is basically the equivalent of you typing google.com, but instead of you typing google.com, it's referring to your loopback address. So it's sending me back to my server. All right. So that's a quick example, I think, for Windows being schizophrenic. I like it. This is a quick example for why loopback addresses are very, very useful. I'm going to go and stop that server there. So I'll talk more in regards to that, why localhost is 127 and the google.com thing here at number 10 when we get into DNS. All right. I guess that's also where we have DHCP. So we'll talk about that when we get over to that. So we already talked about this. We jumped a little bit ahead. So address verification on Windows, you can type in ipconfig, which stands for IP configuration. And on Unix-based machines, aka Linux and Mac OS, you can type ifconfig, which is for interface configuration. And that will show you pretty much the exact same info, which is going to be this. All right. And some of these, you'll also see this thing called IPv6, which we're, I think, getting into not next. We're getting into that one later. All right. We're building up to it. Ooh boy. ARP. Just like the seal. ARP, ARP, ARP. The first useful thing that we're going to talk about for MAC addresses, but also something that you can use to exploit. Any questions so far? You guys have any questions? Go and post them. We're going to keep moving forward. ARP. It sounds like a seal. It should sound like an eel. ARP, ARP, ARP. So ARP, Address Resolution Protocol. What are protocols again? Protocols are just rules on how we will interact with each other. All right. What did I put here as the definition? system of rules that allow two or more entities of a communication system to transmit data via any kind of variation of physical quantity. In normal human world terms, it's just how we're interacting with each other. So this governs the rules of how you use this talking communication method, all right? So ARP is a low-level protocol used to associate logical IP addresses, so your IP address, to unknown hardware addresses, MAC addresses, because these are relevant things, all right? Your computer will have a MAC address. It will also have an IP address. So let's just smash them together so they're related, because they are related at the end of the day. All right? So ARP resolutions are stored in a table of MAC to IP mappings called an ARP cache, located on the host that facilitates traffic delivery on a local network. Where can you find ARP caches? On your computer, on your router, on the switch, all right? That's where you can find ARP caches at. So again, this is going to be a table of MAC addresses to IP mappings. So you have a MAC address. What IP address is currently related to that MAC address? ARP resolution is accomplished when the sending host first transmits a special broadcast packet. Broadcast is the key word there. Whenever we're broadcasting, it's going to be F's all the way in the chat. All right. Can I get some F's in the chat, you guys? F's in the chat. The packet is logically addressed to a specific host, aka the IP address, but all hosts on the network receive it via the physical broadcast address of FFFFFF. This broadcast packet includes sending host's IP to physical address bindings. Since this packet is broadcast to all hosts will update their ARP cache with the new bindings, even if the ARP message was unsolicited. Even if the ARP messages were unsolicited. Again, even if it was unsolicited. If you don't want it, I don't care. I'm going to give it to you, all right? There is no boundaries on what a computer will do to another computer. It is a very violent world. Again, there's no rules here. There's no government. All right, it's the wild, wild west. Unsolicited. They don't want it. You're getting it anyways, all right? Remember that. That is how you could potentially break and destroy networks. There are techniques now in place for mitigation, but that is an important thing to know about ARP. This is happening 24/7. So if we bring up our Wireshark, beautiful, beautiful Wireshark, we can try to pick up some of these ARP packets. So I'm not on the local host, am I? All right, good. So if we go in here and we type in, can I just type in ARP? I can just type in ARP. There we go. Currently, there have been no ARP packets transmitted. Clarification for you guys. What you're seeing is just traffic sent from your computer outward and traffic coming from outward to your computer. This is not showing you traffic on your entire LAN. Your computer would have to sit somewhere else and you would have to analyze traffic somewhere else. This is just your computer, all right? Now, ARP, any devices on my network that were transmitting ARP, we would see them if they were broadcasting stuff. But typically, you will only be broadcasting that special broadcast when you get the new IP address, right? Packet includes sending the host IP to the physical address binding. This is basically letting everyone in your LAN know, hey, I exist. I'm over here. All right? Acknowledge me, please. For the love of God. I'm sick and tired of talking to myself all the time. Please, be my friend. All right? It's you telling everyone that you exist and you are there and letting them know what your mappings are, your MAC to IP mappings, because when you're on a LAN, you're sending typically traffic between each other via MAC addresses. You're not in internet world, you're in LAN world. In LAN world, you talk between each other with MAC addresses. The only way to advertise that is by literally advertising it, broadcasting it. And you will usually also send your IP mapping along with it, because you do have the option to use your IP address if you would like. All right. So the receiving host recognizes its IP and sends its physical address back to the sender. So again, what ARP is doing is a computer is transmitting out and saying specifically for the ARP, it's going to transmit out a IP address, and it's going to say, hey, whose fucking Mac is supposed to be a part of this shit? All right. And you'll be like, oh, that's mine. All right. And you'll send back your address to the sender. The sender can then transmit information directly to the receiver afterwards. ARP works at layer 3 of the OSI model, aka the internet model, because you're first starting and talking over IP, and then you're resolving who has the MAC address. All right. And then there's the opposite of it. All right, which is the reverse ARP. All right, this is you doing the exact opposite. You have the MAC address, but you don't know the IP address of someone. So you'll be like, hey, I know your MAC address, buddy. Tell me what the hell your IP address is. And then you'll respond and tell them what your IP address is. Let's see here. Oh, I got some F's in the chat. Packing spoofing time? Yes. Yes, this is where you can spoof packets. Is there a visual aid to help understand the back and forth? Is that even possible? Yes, there is a visual aid. Let's get a visual aid, shall we? Anytime you learn about these protocols, let's type out the whole thing. Address resolution protocol. When you Google it, there will typically be an image that goes with it, and you are free to look at these images and help yourself out. So this is an OK message. Yeah, we'll go with this one. So this PC right here broadcasts, sends a ARP broadcast. So this is going to be asking everyone, hey, who has this IP address? All right, it's going to send it to everyone, and then they're going to get a response back of whose MAC address is supposed to correspond to this IP address. Now again, this is Honor World. There is no regs in place that say that only one person has to respond. So if you want to play a little prank on your internet or your network here, or on anyone's network you connect to that are sending these messages, you could always respond with them and try to confuse them. And now your messages are going there, someone else's messages are going there, and people are going to get confused. All right. Are there any other graphics here that we can utilize? Oh, this is talking about the hack that I was just talking about, where it's actually Bob that has the IP address, but Eve sends A. Never mind, I have it. All right. There's literally no way to protect against that, because you're broadcasting out. So you don't know that information. So how are you supposed to know one person is telling the truth over another? Let us see if there's any other. I mean, besides these simplistic images, those are like the only other ones I would say you could look at, where you're requesting. All right, you're making an ARP request at first, and you say, hey, I'm looking for this IP address. Send me your MAC. All right, there's a source MAC, which is your computer's MAC address, and you have all Fs in the other MAC address because you're broadcasting out. Everyone receives it, and the person with that address, with that IP address, will then send a reply back. Hey, that's mine. Okay, here's my MAC address. All right. Any questions with that? Okay, that will, does that help? Kawaii. hopefully these pictures help clear it up a little bit. Because again, protocols are, again, how we communicate with each other. So the understood protocol is one person's going to yell at everyone else, and only one person should be responding back to the person that's yelling. That's the whole protocol right there in a nutshell. Nothing complicated, literally at all. All right, and you'll see that as we move forward and cover more and more protocols. They're very simple to understand. They're usually just one person yells, the other person responds, or two people civilly meet each other and do a handshake and then have a conversation. So there are commands you can do. I'm trying to remember them right now. On this bad boy. Oh, what are the... Does it tell me if I do help here? I don't want to do that. I can do all. That's the wrong one. Oh, that's the wrong one. There we go. Okay, so if you're on Linux or Mac OS, you most likely don't need to do this because it's going to already show you a lot of this information. But if you're not, if you're on Windows, type in ipconfig and do a slash, and this is going to be the slash by the shift key, and you can type in all and then press enter. You're going to see a lot more information show up this time. So this time when you look, and you'll need to scroll through and find your Ethernet adapter. So here's mine. You'll get some more information. So I'm using Intel Gigabit network connection. So this is telling me my computer is only capable of communicating up to a gigabit speed. So this is important because if you have a computer that's only capable of doing, let's say, a gigabit, but you have a 5 gigabit connection, guess what? You're not going to get 5 gigabit connections because your computer can only do 1 gigabit. All right. Most of you guys will have 1 gigabit connectors. But also, if you're only paying for 100 megs to your internet provider, you're not going to get a gig either. This is just what your computer is capable of doing. Right below that, you're going to see your MAC address. So this is the MAC address for my computer here. All right. So some people will want to know this, and there is a ARP command that we can do. Let me see. Windows ARP command. It's literally called ARP. So let's go ahead and type in ARP, and we have to give it a command afterwards. I think we can do A. So ARP, and it looked like attack A. There we go. Perfect. So I'm going to go and clear. So if you type in clear, this is going to be all covered in operating systems. So if you don't memorize one of these, don't worry too much. If you type in clear, it will clear your terminal. So if we type in ARP, TAC, or the minus sign, A, this is pretty much saying, give me all of the information, and press enter. You're going to see your computer's current ARP table. All right. You're going to see a bunch of internet addresses and their corresponding physical address. All right. I got a bunch here. So these will be probably other phones that you have on your Wi-Fi. You'll have different computers on your internet connection and so forth. You'll see static, which means that these are not going to change. This relation is going to be the same forever. And then you have dynamic, which means that maybe at any time, you don't know when, this may change and you might need to rebroadcast out an ARP packet, or you might be expecting a new one from someone. All right. Now, there are, and we'll talk about this more towards the end when we talk about our network security. So this is where we really go into hacks, exploits, and other things you can potentially do. But there are several ways you can exploit ARP because it is a very simple protocol where someone is shouting. All right. One way, where is there we go. One way we talked about, which is you can just sit there and basically when someone does an ARP broadcast, you can try to respond quicker than another device and fool everyone else. That is one way you can perform an exploit. The other way is you can just keep broadcasting nonstop. Just yelling and yelling and yelling and yelling and annoying all the other computers on the network. That's what we call a DOS. You might have heard this before. Not a DDoS. This is not a DDoS. This is a DOS, all right? DDoSes are, the keyword there is distributed, right? This is just a denial of service, all right, attack. Denial of service means you are trying to deny someone else some type of service. Internet service, email service, web service. When you do this, this is going to be internet service denial. So anyone within your LAN, you're going to try to degrade the state of the network by flooding it with ARP requests. And there are tools out there that are built into things like Kali Linux, or more specifically, Kali just uses Metasploit. You don't need to download Kali to use Metasploit, which is what most people just use Kali for. You can just download Metasploit. You can perform ARP attacks, ARP floods. And yeah, we're going to call that good for now and just continue forward. I also only have one set. Why do you have more? Because I have a lot of devices on my network and they're probably broadcasting each other, and also probably a bunch of these are a bunch of my dev stuff. Because like these interfaces are different interfaces I have for virtual machines and stuff. Most likely you'll only have one block. So don't worry if ours don't look the same, alright? That doesn't mean anything's wrong with your computer. It's just, you're just less cool than me. It's alright. One day you'll be just like me. Don't worry. Alright, or mine's wrong. Alright, let's move forward with VSLM after a break. Let's go and take like another 3-5 minute break, and then we'll continue forward with this. If you guys have any questions, just go ahead and drop them in the chat and we'll cover them right when we're done with the break. I will see you guys in like 3-5 minutes. All right. We are back once again. Checking the chat. Excuse me. Doesn't look like there are any questions right now. But before we move forward, look, if you guys are enjoying the stream or just here to tolerate it, all right, make sure you tell your friends so they can help learn, so you can help them learn new information and tolerate the stream also, and we can get them certified as a certified rootkit dev holder of our Comp Sci Cert, complete replacement for a college degree, all right, and we will help you get a job. Don't go to college and waste 4 years of your life and a bunch of money, all right? If you're in college right now, look, stay in college, get this cert, and then we'll help you apply to jobs while you're still in college, and watch, you're gonna get a job. You won't even need to finish college, then you can quit it, all right? If you're not in college, then just do this and get a job, all right? You will learn everything you learn in college and way more, all right? Most entry-level devs can't get hired. It is a known fact. You can go Google and research it. You will see it's very difficult. Why? Because no one wants an entry-level dev. They are practically useless because you have to spend months training them, and time is money. Not very many companies can afford that. So the more equipped you are, you can just go at it. All right, you don't need any on-ramp or training. And all this that we're doing right now is fundamental knowledge you need to have because it will be applicable at certain times of your life, especially depending on the job that you're doing. All of this stuff we're talking about will be applicable. All right. If you're liking everything, and especially if you're liking this beautiful, beautiful sweater, look at this. Look at the little panda right here. All right, our little mascot. We also have amazing little stickers. Look at the camera. Look at that. This one is what's on the sweater. All right. We're going to be giving one of those stickers away as our mystery item. They are exclusive. They are only for the 100 Days of Rootkit event. You can only get them during the event, and you can never get them ever again. The only times you can get them is from our free giveaways, which you can participate in, and you can get lots of extra points by sharing about 100 Days of Rootkit and people filling out this with your affiliate link. Or you can get them by donating right here. This is the reward. There's 2 different stickers awards. One is for all of our normal stickers, and the other one is for our exclusive stickers. Additionally, we have our epic t-shirt, which do I have laying around somewhere? No, it's behind me somewhere. I'll show it off on the next stream. And we have our beautiful, beautiful sweater that you can get from donating $150. Yeah, it's a lot, but guess what? It cost us over $50 just to get one of them, all right? So it was $50 for each one just to make, and we need to raise money, all right? We're not trying to break even, we're trying to raise money so we can keep moving things forward. So it's $150. Don't have money for it? Right here. We're giving one for free. No money needed. But you helping us out is absolutely awesome and absolutely huge. If you have a friend with some money, hey, go tell them, all right? Go support us. All right. Let's see here. I want a hoodie. Look, I'm telling you, these hoodies are pretty awesome, all right? They are exclusive, and only during the 100 Days events, we will be giving them away and selling them. So, let us move on. I feel like I was supposed to plug something else, but if I don't remember it, it must not have been that important, right? So next concept here is going to be VLSMs, variable length subnet masks. Basically, all this is subnetting, but instead of, where's our pretty picture? Instead of the traditional way for subnetting is you were required to subnet things evenly, all right? But with variable length subnet masking, you now can subnet things however you want. All right, we kind of said like hinted that earlier when we said that you can do any length you want. I just did symmetric because it's easy and nice looking, but you can do any ranges you want in any like small segments that you want. It's completely up to you. That's all VSLM is, right? Nothing fancy. You might wonder why it wasn't there originally. It wasn't. They had to add it in later. All right. Now, let's talk about gnats. Gnats. Not the like annoying ones. All right. This is a different type of gnat. And we're talking about pats. This is extremely important and something you might have messed with if you've ran your own Minecraft server, Terraria server, whatever server on your computer, and you wanted to like open a port on your router so your friends could join in and connect. If you ever like did that, you messed with both of these. This should be vaguely familiar as we move forward. Oh, that's what I was going to say. Let's look through. We've talked about all of these guys. We talked about these classes. ARP, ARP cache, reverse ARP, IP broadcasts. Did we talk about IP broadcasts? IP broadcast addresses. They're just like the MAC addresses, except MACs are going to be all Fs across. IP broadcast addresses are going to be the same, ones all across, and ones all across are 255, 255, 255, 255. So if you see that address come across, that is a broadcast address. And if we actually look in Wireshark and we do our IP adder and we say it's equal to 255.255.255.255, and I'm very surprised there are no broadcast items. There's usually OS broadcast items, but it's the same thing. When you do 255 all the way across, it's you broadcasting to everyone on that internet connection that you have something to say. And now we're all the way down here to gnats. All right, we are pretty close to the end of our section 6 here. Pretty exciting. So let's get into gnats, shall we? So gnats are network address translation and PATs are port address translation. All right, exact same thing, except one is for your network, aka IP addresses, and one is for ports, which we'll get into what ports are here in a second. So NAT is a function of connecting multiple computers to the internet or any other IP network using one or multiple routable IP addresses, also known as network masquerading or IP masquerading. It involves rewriting source or destination IP addresses of IP packets as they pass through a router or firewall. NAT maps unregistered private, reserved, and local IP addresses to registered public routable global IP addresses, allowing your home user or small business to connect their network to the internet cheaply and efficiently. Oh, they save the day. It's just so awesome. There's also this thing called static NAT, which is designed to allow for one-to-one mapping, and dynamic NAT, which provides the ability to map an unregistered IP address to a registered IP address from a pool of registered IP addresses. Oh man, that was a lot. Let's talk about it. We already have talked about it, and I will now show you how we've already talked. Oh my, get ready to give the pitch. Jimbo, are you about to raid me on Twitch? Oh boy, y'all be ready for this raid. All right, let's go ahead and click on new, don't save, and let's bring up our good example of our little network here with our little router, and how your router is both in your LAN and out here in internet land, and it connects it to, it's connected to that. And we talked about how we had two different IP addresses. So our router was 92.168.1.1. And our public IP, I don't remember, it was 68, let's just say 68, 1, 2, and 3. All right? So, oh my, party of 8. That is a massive party. Holy crap. Welcome, 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 all of y'all who are rating us. We're talking about networking today. We're going over IP addresses, MAC addresses, how you can potentially break and destroy a network. Right now we're talking about, I know all of you guys watching Jimbo are into Minecraft, all right? And you guys want to host your own Minecraft server at home, all right? We're talking right now about how you get that Minecraft server you're hosting on your computer out to the open network so your buddy over in Nigeria can help and connect and help you build your house in Minecraft. All right? All right. So we went over, if I can get my paint back up, how your router has 2 IPs. All right? One IP address is within your LAN, your local little area, all right, and one is exposed to the public internet. What NATing does is it's used all the time. When you, let's say you and your special little computer here, all right? Oh yeah, look at that beautiful drawing. You got your little computer here, and let's say your address is, I'm not going to write the whole thing, I'm only going to write the last 2 octets. Let's say it's 1.2. That's your IP address. Guess what? When you reach out and talk to google.com or try to go to your friend's Minecraft server or Gmod server or whatever server it is, anything that's not within your LAN, how do you connect to it? You don't send them your computer's IP address. I know, shocker. Media tells you and movies tell you that that's your IP address and now you've been hacked and claimed and so forth. No one knows what your computer's IP address is right here outside of your local network, right? It is never, ever, ever, ever 20,000 more evers sent outside of your LAN. It is only kept within your LAN. What address is sent is the address on your router here, all right? This router is your gatekeeper. He is your savior. He's your guardian, all right? He is there to be your middleman and be your gateway keeper, right? He, on your behalf, will sacrifice his IP address to the internet. So whenever you reach out to the internet, all of your traffic will be your router's IP address. And so when things come back from the internet, so once you're done visiting Google and you come back and it comes back to your router to try to send to your computer, it must be first sent to your router, all right? And then your router will have a NAT, all right, a little table where it's like, hey, okay, I see that you sent out traffic and now I got that traffic and I need to send it back to you. I'm going to do some translation of this traffic. I'm going to keep a table and a record of who sent me what and who needs a response what. So your router will do a translation and now let you receive that data and keep that communication alive. It's your middleman. That's what NATing does. It's the function of allowing your IP address in this safe area be potentially accessible to the outside internet. Now, let's talk about you hosting a server. You're working at Google now. All right, you're a bad boy. No, you know what? Even better, Roblox. Why did I bring up Roblox? Well, we've linked to this a million times, but I'm gonna tell you guys right here. If you go to levels.fyi, they'll show you the average salary that a dev is making at any given company, and it's updated pretty regularly. Why do I talk about Roblox? Well, if you go to the pay report for 2022, maybe not the pay report, where is it? The top paying companies, all right, for 2022. If we go, oh gosh darn it, why is this moving around? Entry level. I thought I was already signed in. Here we go, Roblox. is one of the highest paying companies. Here we go, especially at the principal level that you can work for. Roblox, out of all things, I know it's pretty crazy. So you can see their average compensation is this. So quite a lot of money. This is an addition of your base plus stocks and then bonuses. All right. So let's say you want to work at Roblox and help them host and run some servers. Natting is going to be extremely important because how things work at your house is exactly how they work for everyone else. All right. There is no difference between businesses and what you have. All right. The hardware may be beefier. Oh, thank you for the follow, Catoxy. Catoxy? Am I saying that right? Hopefully I am. It's howdy. I like that picture. All right. So like I was saying, there's no difference between the tech and how things function between your house and you working as an employee at Roblox. And when you want to host a server, they also have a router. All right. They also have computers. They also have wires that connect everything. There's no difference. They're using the same tech. They just might be using bigger boxes. All right. Bigger routers. So you're working at this company. Let me use black here. All right. And you're hosting a massive server. Let's say this server costs $100,000 just to buy and purchase and set up. It has everything. All right. The biggest of the drives, the biggest of the processors, the biggest of the GPUs. All right. It is massive, awesome, and cool. And you have this set up as the best game server ever. I'm going to put G on this because it's a G, all right, for gaming server. All right. That's the only way I intended it. All right. So you want to now have people connect across the internet to your awesome, amazing new Roblox server that you stood up for Roblox. All right. Because you work at the company. Guess what? The company also has a router. That router works just like your home router. All right. Inside here is your LAN. And out here is the internet. Internet. Look at that. Oh. My handwriting's so beautiful, you guys. What can I say? All right. So your router is living on both sides. All right. It lives on the edge of both. It is an edgy piece of hardware. So it connects out to the internet. Guess what? Your server is just straight up cannot allow anyone to connect to it outside of your LAN. That's just how things work everywhere. No matter where you are, you're hosting something in the cloud. Guess what? Same limitations are there. You're at home, same limitations. At a business, at work, at a school, at a government agency, they all use the same thing. All right. No one can communicate to your server unless you set up your NAT table properly. So what does that mean? It means that you are allowing people from the wild internet to hit your router, and you're saying, hey router, allow that traffic through. I know you want to block it. I want you to allow it through. And when you do allow it through, only send that traffic to my server, to my cool server. All right. That's what a NAT table is for. It's for that translation between internet and LAN. And when you're going through these two distinct areas with different IPs going on, it will do the translation between both of them. All right. And that's where we get into PAT. All right. Well, so static NAT would be that this is just has one IP address here. So your server has only one IP and your router only has one IP address. And that's how it is. And so it's a one-for-one relationship. NAT means that there can be potentially, your router could potentially have multiple IP addresses. All right. Your server will only have one, but your router might have multiple. So that's dynamic NATing. All right. And this you'll see a lot if you look at, let's go to what are Google's IP ranges. So if you go here, you'll see some of Google's IP ranges. This is specifically for their DNS server, which we'll talk about DNS later. But Google owns the IP 8.8.8.8 and 8.8.4.4 and these IP4 addresses. They also own multiple different IP addresses, all right? That's not the right one. There's my paint. There we go. What the heck? It's not paint either. Paint. What? I swear to you guys, I'm clicking on paint and it's disappeared. There we go. All right, perfect. So they own different IP addresses, and you can basically hook up multiple IP addresses to the same server if you want. Now, there's this thing called PAT, which is in regards to your ports. We haven't talked about ports yet. Does anyone know what ports are? There we go. Perfect. Ports. All right. Let's see if anyone posted anything. All right. I'll go ahead and give you guys the answers. So we talked about how your IP address has two parts to it. One is the network, aka the street you're on. The second part is the host, aka the house you live on. For this example, I'm going to use an apartment building because it makes a little more sense for an apartment building. So an apartment building will have a street it's on, and an apartment building will have a building number. There's just one building number for the apartment. That would make up an IP address. But how do you send mail to everyone within an apartment building? You have these things called ports on your computer, all right? And ports are basically the mailboxes in an apartment complex. An IP address will get you to the apartment complex, but you don't know where to go in the building unless you also know what room you're supposed to go to, which will be the port you're supposed to go to. All right, and ports are really, really important. Your computer has up to 65,535 ports. This number should look familiar because again, if we go back to our data and basic math that we talked about when we talked about bits and bytes, particularly when you have an unsigned integer, by default they are now I'm forgetting the term, but you'll have, and now it's gonna bug me if I don't remember. No. Okay, regardless, usually this means that it's going to be 2 bytes in length, because 2 bytes, the total of 2 bytes of data is, as an unsigned integer, is going to be this. Like I said, you're going to see these things reoccur a lot if you haven't already naturally, as you being on the internet. 255 or 256, 65535. You'll see that a lot. Especially, I bring up Minecraft, but I'm very serious about Minecraft. If you've ever hosted a Minecraft server, you will see they use a port number, literally the max port. They use port number 65535. If you don't believe me, let's go ahead and type in Minecraft port. And that is... Why is this being difficult? There we go. No, that's talking about server ports. Did they change theirs recently to 25565? This is a lie. This is some fake news. They must have done that recently. Alright, well, believe me on this example, right? Just entertain me for a second. It used to be 65536. That used to be their number, and that's the max port range that you can have. Because you can have anything between technically 1 to that. I used to make Minecraft servers when I was 10. It's always been 25565. Okay. Dang. Okay, I don't know what I'm remembering then, but there is something that uses that port by default, alright? Oh man, proven wrong on stream. It's right. We're all about making mistakes here, because guess what? The only way you can learn is by making mistakes. So make sure you guys are making mistakes a lot. That's why our anthem, that music I play at the very beginning, before the cool one, all right, the child one, all right, oopsie, all right, because you guys need to understand, to be good in this field, you need to mess things up a lot. You need to break things. It's okay. Do it. That's the only way you're going to learn and move forward. So, ports have ranges they can be, and some of these ports are more important than others. So let's see, computer ports. We'll talk about, oh no, computer networking ports. We're going to do a Wireshark example, and we're going to look at this. You guys are going to get lots of examples on this. Where is the Wikipedia? Here we go. So Wikipedia will give you a breakdown of these ports. And of course, they're giving me a poor breakdown. All right, we got some stuff in the book, I think, next about it. So we're just going to leave it for that, because I know our book will do better. But if we go to Wireshark, all right, which you guys can interact with right now, go ahead and let me stop this. Click on any of this stuff. All right, will this stuff work? Yeah, click on any of this stuff. In here, in the IP section, we only talked about the IP addresses, which you can see here at the bottom is your source and destination IP address. And if you click on them, you'll see in the packet of data that was sent, it will highlight the actual bits of data that were sent to you that signify where your source and destination address are. And if we click on the whole IPv4, this is your entire IPv4 header, right? And inside of that, these parts are your addresses. But also in here, I think it's going to be on the next section. So on the next wrapper is going to be your transportation, so aka OSI model, transportation. In here, you're going to have ports, all right? We'll talk about what UDP and TCP are later, but in here, you're going to see ports, all right? So you can see I'm talking, this traffic is on port 137. So now we can start piecing things together, all right? Because ports for computers are usually one-for-one relationships with services, programs, applications that you run, servers that you're running, games that you're running. They will have ports that are usually one-for-one tied to them, all right? So if we look at our IP addresses, we can figure out now who's talking to who, all right? And from that, we can then see what they are talking about, aka the application they're messing with. So if we Google what's on port 137, this is what's on port 137, a program called NetBIOS, all right? And you can learn all about it if you click on these links here, and it will tell you all about NetBIOS, more than you ever want to know, and how you can potentially exploit that service. So it's particularly for file sharing and print sharing, right, on Windows computers. So you should only see this on Windows computers. If you're running a Mac OS or a Linux computer and you see this, you should be a little concerned, all right? You shouldn't see it. There are great sites like Speed Guides who will have pretty much every port cataloged and what they've been known to be associated with programming wise or exploit wise. So you can see a bunch of Trojans here that utilize this port. All right. So ports are like mailboxes, and these mailboxes are for assigned programs. A fun port that you use all the time, you guys are using it right now. You're on the internet, right? The internet is composed of two ports, all right? Because there's two types of sites that you can be accessing. There's one site that's called HTTP, which is unsecure, all right? That's the HTTP that you see at the very beginning of a URL. When it's HTTP, that is unsecure, plain traffic being sent. Anyone listening to you, all right, put your tinfoil hat on, anyone listening and spying on you can see everything you're doing perfectly. No work is required. That is on port 80. So if we type in what's on port 80, you'll see that HTTP comes up. So if you're running a web server that is running HTTP traffic, it's going to be running on port 80. So remember XAMPP we looked at earlier? When I started this guy, it has a little section here called ports. I don't know if you guys can see it very well, but it says it's running on port 80 and 443. And we're about to get into 443. So normal web servers run on port 80. 443, guess what? We said HTTP is port 80. Right here, when you usually go to a website, it should always be secure. How do you know it's secure? It's using HTTPS, which means that your data is 100% encrypted and anyone listening to your traffic cannot see what you're doing. It's completely encrypted by default. All right, that is done on port 443. So that is your encrypted HTTPS traffic. It's HTTP, but it has TSL and SSL encrypting it. All right, TSL is what's used right now, and that's what makes it HTTPS. It is completely secure. So with that knowledge, you must always have a port address with your application. You can't just tell people go to an IP address. It doesn't make any sense. You need to tell them what port or what service they're going to be using. So when you are doing this forwarding of your game server, not only are you going to forward your IP address of your local machine, but you will need to do port forwarding also with PAT. PAT will do that port address translation. All right, that's what allows people to connect to you. So any of you guys that are experienced with hosting things like Minecraft servers, specifically locally, you have most likely had to do this on your router. Let me see if I can give an example on my router. I'm going to log on to it on a different screen just to make sure there's nothing fishy showing. 192.1.1, no, 168.1.11. Let me log in here. All right, let's go to sys device. Oh, advanced. Security and firewalls. General. Here we go. Port forwarding. All right. I don't think there's anything crazy on here, so we're good. Let's give this example. Let me pull up the stream again. Why would someone use HTTP over HTTPS? HTTP is plain traffic. It's insecure. So let's use Wireshark for something useful. I have this web server running right now. This web server is running right now on port 80. So let's use Wireshark for its intended usage. Seeing traffic and potentially snooping on people. So let's start snooping the traffic, and I'm listening to traffic right now. Lots and lots of traffic. Now me, as an individual, I want to go to my favorite website, all right? Let me 192.1 or 168.1, or actually localhost. Localhost. All right, this is going to be the loopback address. You could type in 127.0.0.1. Also, it will do the exact same thing. All right. I just went to this site. This site is not secure. It is running on port 80. Also, fun fact, your web browser can handle any port. All right. So if you do a colon at the end of your website's address or your IP address, this is how you can dictate what port you want to go to. So we can say port 80, and you'll see it goes to port 80. It gets rid of it because it already knows if you're doing HTTP, you're on port 80. Same thing with localhost here. I can do colon 80, and now I went to port 80. And again, this is already HTTP traffic, so it just gets rid of the redundant factor at the end when displaying it here. But now I can go to Wireshark, and let's go ahead and stop this. And let's go ahead and filter for the IP address. IP adder. And let's filter for 127.0.0.1. Bam. If we look at this traffic, and here we go. Bam. This is the web page you just visited. All right. We can literally see in plain text right here, I can see what was on that web page. So there's a bunch of information that's sent about a web page that's besides what you see right here. So this is some of the metadata that you get. If we go to the next packet here, we can see more information that is being sent. All right, let's go to the next packet until we can find this could not connect to my MySQL section here. So let's go to the next packet of information, because this again is all cut up. So you might have to go to multiple packets to see everything that you would like. Oh, here we go. See this text right here? Could not connect to MySQL because, and then it will continue. Oh, never mind. It just says because right here. You can see in Snoop on this traffic, it is not secure. HTTP is just plain text being sent across the internet. I'm emulating right now the internet. Even though I'm sending it to myself, it works exactly the same way if it's across the internet. But if I visit a site, for example, my router, so if I change this IP address to 192.168.1.1 and search that, maybe, okay, let me turn on this sniffing again. All right, sniffing on. Let me refresh this page. Come on, why are you not showing me any traffic? You're really ruining my example here. Okay, well, I'm not sure why the traffic isn't showing up, but your traffic will show up here. Am I on the right? Hold on. Let me, yeah, continue without saving. Let's try this again. Let's refresh and stop and then say IP adder. Here we go. Now, this is the network traffic of me talking to my router. Looks like there's a bunch of other stuff in here. This one is me right here. Trying to look for the packets exactly, but regardless, it doesn't matter. All of this stuff right here is the encrypted traffic. This is HTTPS, and as you can see, it's unreadable. All right, you can't read any of this. It's just all encrypted junk. This is why HTTP is important, because it encrypts your information and it makes it so you literally can't see what is going on. You can't, that traffic that you have is uninterceptable. All right, it's useless. Does that answer your question, Kwai? So going back to our PAT, talking about PAT and NAT, if you've done port forwarding for your game server, which you can see I got some game servers here that are forwarded, you typically have to, so application is purely a note. So you can see some applications here. These are purely notes, just notes that you leave, all right? They have no functional quality at all. The port here is the port that you want to use, all right? So this right here is the original port, aka the port on your computer. And this is the port you want to be exposed to the public internet. So you can choose ports to use, and you can mix and match them. So if your computer, I'm gonna write over here, if your computer is running something, so let's say your computer is on 192.168.1.2, and you're running your game server on port 1, 2, 3, 4. All right, and you want to allow people from the outside internet to connect to it. On your router, you need to set up that port forwarding, which does not just port forwarding, aka PAT, but it will also do NAT. All right, your router's public address, let's just say it's going to be 1, 2, 3, and 4. Let's say that's your public IP address. You don't have to use port 1, 2, 3, 4 if you don't want to. A part of PAT allows you to change this to any port you want. So you could have it as something super cool like 5555. When traffic comes to your router at this port, it will now auto forward it to your computer here. All right, that's what you can set up here. All right, any questions on that? And that's the end of this section. We have lots of videos that we can link you guys. Oh, I see you said wait, no. Go and ask your question. Don't worry, I can go back. We have lots of videos that can talk about MAC, ARP, IP addresses, NATing. All right. We have some assignments, but we won't be really sending these to you guys. This will all be available in our 2.0 state on Project 26 when we launch it towards the end of March. It may be just a couple of our modules that are initially on there, and we'll add more later on, but it is a new epic site that's going to change the world as we know it when we launch it. And it will be in a beta state when we launch it at the end of March, and we will continuously develop it to get into its final release state, hopefully by summertime. It's going to be awesome. That's all I got to say. Go ahead, Quiet. Answer or ask your question. Let's see, IP, but Mac. It's not right. I rewatched just to be sure, but I think I might still be confused. So you would only want to use HTTP in order to be readable if HTTP, no. You don't ever want to use HTTP. You don't want to use HTTP ever because people can read it. So let's go to picture time over here. Here are you. Oh, why does it exist? I'll tell you why. Because computers in the early internet were very simple, very weak, and people were very naturally trustworthy. I don't remember. We're trusting of each other by default. So in the early internet, things were completely just cleared. They were just sent over the wire, and that's just how they were. Then as the internet became bigger and bigger, a lot of hacks happened. It was really easy in the early internet for people to hack everything, all right? Most of the kids and the kid hacking and stuff that you hear about in the news, those times are pretty much over. It is very hard for someone to just easily stumble over an exploit like it was in the early days, because in the early days things weren't really protected at all. And you'll see a lot of our systems in the internet and on computers and operating systems, Linux, Windows, Mac OS, they're all equivalent in how they're pretty much built on top of crappy patch on crappy patch on crappy patch. There's a lot of weak, unstable foundation in all of this, and people are continuously building on top and making like little patches to kind of hide the crappiness of it all. Some people are taking the time to rethink and make everything from the ground up, which is the best thing they can do, and you will notice it in performance. But most things are crappy patches. The funniest thing is if you go to CMD, is built into your computer. Microsoft open sourced this recently. It was funny because if you looked at some of the code for CMD, you would see that there were comments left behind by the developers back in 1984 saying to do, didn't implement X, need to do this later, and it was never implemented, which could potentially be an exploit. So HTTP is exploitable. It is old technology that is still supported today, but you want to use HTTPS when you can. Why do you use HTTP? Because it's easy. Encryption is a lot of extra stuff I have to add, certs I need to grab, things I need to plug together in order to get it working, all right? In order for things to be encrypted properly. And that's still not good enough, because if we go back to my router over here, this is completely encrypted, perfectly encrypted. No one will be able to read your traffic, but Google will show you this little message that says that it's not secure, because you encrypting everything yourself isn't really good enough. You have to then basically tell someone else. These are called certification authorities, which we'll get into in a later day. It's basically a public rep that basically tells everyone else in the masses whether you're legit or not. So you need to just not encrypt your stuff, but also get someone to vouch for you that your stuff is legit. So it's a lot of hassle. So a lot of people will not mess with it at all until they have to have a server go live, and they'll only have it working on their live servers. But anything internal, they usually won't even mess with it because it's too much of a hassle. That's why things like AWS, so cloud services, are so popular, because they handle all that hassle for you. So going back to my example I was writing here, here's you, right? We got Kauai, and here's me. I'm a bad person, right? I'm a bad guy. I don't look bad, but I'm bad, all right? This is me, this is Elijah. And this is your lovely bank account. Look at that. If I can spell bank correctly. Look, Rootkit, we're in some hard times. We need some money. I'm out here grinding for 100 days so we can make a couple dollar bills and keep the lights on, all right? I'm kind of on a desperate state, all right? I'm a little crazy right now, all right? I need money. So I see that you connect to a bank that uses HTTP traffic that is unsecured and unencrypted, all right? So what do? Using my computer skills, I set up something called a man-in-the-middle attack. We are going to go over this stuff later, all right, in a later date. So if you don't get it completely right now, we are going to talk about it all over again. You can perform a thing called a man-in-the-middle attack, where I sit here in the middle of your guys' connection and I run something like Wireshark, and I intercept all of your traffic. And when you talk to your bank and plug in your password and username, guess what? It's unencrypted. So I can see it. I grab your password information. Guess what? Rootkit doesn't need to do no more fundraisers anymore. We got money. We got money because I log into your bank account and I transfer it all to Rootkit. All right? That's why you don't use HTTP at all. If you are on a live server, this is like anyone here. If you are ever on a website, a public website where they are having you log in, do not log in. Do not make an account. Do not trust that website, because anyone can compromise your account there. You can visit HTTP sites just fine. That's okay. Who cares if you're visiting a site that's unsecured? If there are things that require sensitive information, like logging in, payment information, your ID, social security number, stuff like that, you need to make sure it's encrypted, all right? You don't want to send that stuff over a clear connection. You don't know who's listening, all right? Let's see here. Sounds like more work than trouble. I mean, depends on the payout, all right? That's the other thing that people are generally paranoid about, is being hacked. No one cares about you. You're not special. I'm sorry, but you're not. No hacker is going to come after you unless you have a lot of money. If you have a lot of money, you're worth my time, because hacking takes time and you want to make your time worth it. Most people aren't doing hacking just to do hacking and troll people, all right? The only people do that are hacktivists, all right? Everyone else, 99% of people, they're out there to make a quick buck. That includes foreign governments. North Korea has some of the most notorious hackers. And you know what they do? All they do is they steal and rob and get money, because they can't make any money because no one wants anything from there, because nothing grows there, because it's just a broken country. So how do they make money to fuel their nuclear programs? They steal it all right? So let's see. Oh no, Elijah, please no, you don't have to do this. We can work something out. Joke's on you, I have no money. Whoops. Wow, that's awesome. Whoops. I don't know how you sent a message without any text, Matthew. That's quite impressive. So the hacking techniques, we'll go over more on how you're able to do it. Wireshark is something you can use. It's not meant to, so a lot of the programs for that can assist you in exploiting aren't originally meant for that. They're meant for network security, and you'll usually see the word security thrown around a lot in this realm. That's the professional term. It's meant for you're running a business or you have your own computers and stuff, and you want to make sure you are secure and nothing fishy or wrong is going on. They just conveniently also work for you to do the opposite if you want. It's a double-edged sword. It's like, I don't know, it's like a knife, or if you're in the US, like a gun. Guns are great if you want to protect yourself. Also, guns are great at killing people. It's a double-edged sword, all right? Same thing with hacking tools. Maybe type to space, I guess. I didn't know spaces were like that. Is signing into apps more secure than websites? No, they use the same thing. That's the thing, is people also think websites and apps are built completely different. No, they're the exact same. All right, they use the exact same technology. There's nothing different. Just like how the internet routers are the same at your house as they are at any business on Wall Street, at Google, anywhere. They're all the same hardware. Same thing with apps. Apps use the exact same tech to secure them as websites. They all use HTTP traffic. Not all of them. Most of them use HTTP traffic. Sometimes, depending on the game that you're playing, they're doing some other traffic, which we'll get into, don't worry. But this is the standard way of transmitting data across applications. It does not matter what the app is, a game, a website, whatever. It is a standard. Between PowerShell and Command Prompt, which one is better and easier to use? Use PowerShell. Command Prompt is old. It's outdated technology. PowerShell does everything Command Prompt does and more. We'll be going over that in the operating system section. Sorry to bombard you with all these questions. No, that's all right. This has been an epic day because you guys have been really on top of it, super interactive, asking lots of questions. So it's been super awesome. We actually didn't even get through everything on today's list, which is awesome because we were, well, I mean, there's a lot of items here, but also you guys were asking a lot of questions, so it's super awesome. Any more questions you guys have, because that's all that we're covering for today. Any other questions you guys have at all in regards to what we copied or talked about or what we covered? That's all for now. Can't wait to continue tomorrow. Epic. All right. If that's all the questions that you guys have, maybe, oh, never mind. That was earlier. If that's all the questions you guys have, that will conclude today's lesson. We'll be back at it again tomorrow at 7 p.m. and we're going to be covering IPv6. We already talked about ports. I don't know if the... What's the next thing on here? Yep, IPv6. So we're going to be covering IPv6 and what the difference is. And there's a lot of differences. Where is the... There we go. IPv6. We're going to be talking about IANA. Oh, you guys are going to love this. Because, again, all this stuff is built off of trust. If there's trust, that means there must be some type of governing body, since governments themselves don't do anything about it. So there is a governing body that's completely optional for you to acknowledge. That is IANA. We'll talk about all these things that are all parts of IPv6. We'll get into NDP. We're going to get into ICMP, all right, not UP. And hopefully we can get into TCP also. We'll see how deep we can get. But definitely 10 is going to be fun for y'all. This is going to be a lot of applicable stuff, including, you can see right here, we talked about HTTP. You guys have heard a thing called URLs before. HTTPS. Don't worry, we're going to go over all the stuff all over again. Where's the donate link? I pasted it earlier. Here it is right here. Like I said before the stream, also, I don't know why, put this right here. I don't know why, but these, I have the full links in the YouTube stuff. When I go live on Streamlabs, it cuts these off. I don't know why, but I'm going to go in after the fact and update all of these descriptions for you guys. So sorry, I know these are wrong. I don't really know how to fix it, but I will fix it if I can. Were you going to donate, Jimbo? Is that why you asked about the donate link? Didn't you ask about it earlier? Like the beginning of the stream? No, you asked at the beginning. I'm looking at the chat. You asked at the beginning of the stream and I pasted it. Couldn't because I was streaming. Oh, well, we're about to end. Like, this is the end, man. You missed again. Yeah. Hey, you can donate right now if you want, or you can wait till tomorrow so it's a little... Alright, go ahead, man. Don't care. Can I get... can the link get put in the donation part of the Twitch page? Is it not there? No, it's not. No, that's not a bad idea. I can do that right now. Let me go ahead and paste that in. Where is that? Paste it right here. And donations... Paste it right here. Submit. All right, it should be live now. Why are the links not linked? Oh, it wants me to put it in this format. Let me put it in the format it wants. Stream donations. And then we'll do like that and do it like this. And do a copy and then a pasta. Where did I want to pasta it at? There we go. Submit. Well, it worked on one of them. Not copy. Oh, this part right here. Paste, submit. All right. Now it's live on the Twitch stuff, the stream donations. Jimbo said, then I will do it tomorrow since the link will be there. And also now it's bookmarked. All right, do it tomorrow. More people will be there. It'll be a little more hype, a little more fun. All right, I will see you guys tomorrow on the next one. That's the wrong screen. Here we go. That's the right screen.